Fast radio bursts, FRBs, are radio pulses so short they last milliseconds, yet they can be detected from billions of light years away. Most appear once and vanish forever. Some repeat, sometimes in clusters. Each burst arrives distorted, like a message damaged by the universe itself, and that distortion is one of our biggest clues. An FRB is a sudden spike of radio energy recorded by radio telescopes. It's not visible light and it isn't a sound. It's a brief radio flash that ends almost instantly, which makes follow-up difficult. But inside that short signal, we can measure patterns that reveal distance, plasma along the path, and extreme conditions near the source. The first FRB discoveries looked almost unreal. Too bright, too short, and not matching known pulsars or typical radio flares. At first, scientists had to rule out human interference and instrumental artifacts. Once more events were found, it became clear FRBs weren't a single anomaly. They were a real cosmic population hiding in plain data. Radio observatories don't film FRBs. They continuously record streams of radio data and search for millisecond scale spikes. The hardest part is confirmation. Satellites, electronics, and local noise can mimic bursts. Real FRBs must show consistent signatures across frequency and timing that match propagation through space, not a nearby device. A classic FRB clue is dispersion. Lower frequencies arrive slightly later than higher ones. That delay happens because the signal passes through ionized gas, plasma, on its journey. The more plasma it crosses, the bigger the delay. Many FRBs show far more dispersion than our Milky Way can explain, pointing to extragalactic, and often very distant, origins. For years, FRBs were just somewhere in the sky. Then better localization pinned some bursts to specific host galaxies. Suddenly, FRBs became astrophysical objects with addresses. And the hosts were diverse, some in active star-forming regions, some not, suggesting FRBs may come from more than one kind of engine. FRBs fall into two behavior groups, one-offs and repeaters. A one-off could be a catastrophic event that destroys the source. A repeater must survive, which rules out many single explosion ideas. That single fact forces different models and makes repeating FRBs the center of the mystery. Repeaters don't behave like perfect clocks. Many show burst, storms, with rapid activity, followed by long quiet periods. That suggests the engine can switch between active and silent states, or the signal is sometimes blocked or redirected by the environment. The puzzle is not only what produces the burst, but what controls when we can see it. Some repeaters show hints of periodic activity windows, times when bursts are more likely. That points to geometry, orbiting companions, precession, or rotation-linked viewing angles. But periodic windows don't explain the burst physics itself. They only explain why the same source can look silent for weeks, then suddenly light up again. A crucial clue came when an FRB-like radio burst was detected from a magnetar in our own galaxy during a high-energy active phase. That doesn't prove magnetars power all FRBs, but it proves they can produce FRB-like signals. After that, the debate shifted from, is it possible, to, which FRBs, under what conditions, and how often? Some FRBs show strong polarization, meaning the radio waves carry information about magnetic structure. In certain cases, the signal appears heavily rotated and distorted by intense magnetized plasma near the source. That suggests extreme environments, like young neutron stars, dense nebulae, or energetic regions. But not all FRBs show the same magnetic fingerprints, reinforcing the idea of multiple source types or stages. Even if two FRBs came from similar engines, their signals can be reshaped by the journey, turbulence, scattering, and plasma. Weather between galaxies can stretch, split, or brighten parts of the pulse. That means some mystery may be the path, not the source. FRBs are both events and probes. What you see is engine plus universe combined. Current models include magnetars, compact object interactions, and extreme plasma environments near energetic objects. The diversity of hosts and behaviors makes a single explanation hard, The cleanest possibility is that FRB is a label for similar radio outcomes produced by more than one physical engine. The challenge is separating categories with data, not guesses. Repeaters are gold because you can return to the source and study the environment, host galaxy type, region, and long-term behavior. Every repeated burst is another data point, polarization, frequency structure, and timing. Over time, repeaters allow astronomy to move from "we saw it once" to "we can test models." Dispersion makes FRBs powerful tools for mapping otherwise invisible ordinary matter in intergalactic space. With enough localized FRBs and distances, scientists can infer how plasma is distributed along the cosmic web. Ironically, the signals we don't fully understand may become one of the best ways to measure what the universe is made of. Fast radio bursts are real cosmic pulses with real physics inside them, yet their main engines are still not fully settled. Some repeat like a system that refuses to shut down. Others flash once and disappear forever. Comment your best theory, magnetars, binaries, or something else, and subscribe to World of Mysteries for the next investigation.